Hi everyone, in this we will learn about glitches and hazards. In digital design, signals can sometimes behave unexpectedly due to timing differences in logic circuit. These unwanted behavior are called glitches and hazard. Precisely, a glitch is a temporary unwanted pulse in a signal caused by unequal propagation delays in logic path. Whereas, a hazard is a condition in a combinational circuit that can cause a glitch. Let's see the types of hazard. There are two types of hazard. The first one is a static hazard. A static hazard occurs when the output is expected to remain constant but it briefly changes due to delay. It is of two types. The first one is a static one hazard. In a static one hazard, the output should remain at logic 1 but it briefly drops to 0. As an example, consider the function f equal to a bar b or ac. Suppose b equal to 1, c equal to 1 and input a changes from 0 to 1. Therefore, before the change, meaning a equal to 0, a bar b equal to 1, ac equal to 0, which results f equal to 1. And after the change, meaning a equal to 1, a bar b equal to 0, ac equal to 1, which results f equal to 1. Ideally, the output remains 1, but due to propagation delay difference, the output may briefly drop to 0. This is called static 1 hazard. Similarly to static 1 hazard, there is another static hazard called static 0 hazard. A static 0 hazard occurs when the output should remain 0 but it briefly becomes 1. The another type of hazard is called dynamic hazard. A dynamic hazard occurs when the output is expected to change only once but instead it changes multiple times before settling to its final value. This usually happens in multi-level combinational circuit due to multiple delay path. Now let's see the different technique by which the hazards can be prevented. The first technique is to use hazard-free RTL coding. It is recommended to use synchronous design with flip-flops and resistors. And also it is recommended to avoid purely combinational logic for critical output. The another technique is to use path delay balancing. In this, we equalize delay among different signal paths, which helps to prevent the hazard. And the third technique is to add redundant term. For example, in a function f equal to a bar b or ac, we can add a redundant term here bc. Here bc is a redundant term and it is independent of a, so it maintains output stability during transition and remove the hazard. So to conclude, hazards are timing related issues in combinational circuit caused by unequal delay. And by using the proper design techniques like synchronous design, delay balancing and redundant logic, we can minimize or eliminate the glitches. Thank you for watching and see you in next video.